So we need to do the raycasting thing. Sweep component. Sweep component. We don't actually have a raycast example, do we? Okay, well, we know where to find them. So it's going to be ray trace direction in our physics utils. And we pass in the starting pause, so step 1 start. We're going to go in our direction, which is going to be step 1 direction. We're going to do step 1 ray distance. The collision channel is going to be the collision channel for our actor, so we need to go snag that. I think we have an example of how to snag that up. In snap to floor. Where you be? I think it's right here. Get yeah, here's the collision channel for us. So this will be, we should probably just like make a function here for ourselves. And call it, like we've got calculate bounds, we should also do like a calculate channel. Say like get collision channel, get physics channel. And the thing is, there are different collision groups for different things. So like you could have a wall that an enemy couldn't get past, but you could get past. So not bad. Let's throw that down where the sun don't shine and forget that that ever exists. So we need the collision channel right up here. Let's do phys_chan. So phys_chan will be our test. Then we need to do our hit array and our ignore actor. So we're going to do hits. Excuse me. Hits, and then I think it's m_actor. So we're going to do if on there because it'll return if we actually hit anything. So if it hits, we're actually going to break our loop and get out. So info log, we have struck an object with our step 1 raycast. What, the small valley and the ram tops? What are you referring to? Let's see, so step 1 raycast will do it. We probably do want to actually grab the hits. Yeah, this is a, let's just do step 1 hits. We're being a little explicit with our variable names because we'll probably break this out into smaller functions later. Oh, I just know of the quote and the vulgarity associated with it sometimes. I'm not really a very well-read person. I mean, I've read books, you know, they have like pages and things like that, but haven't really read too many books since like I got out of college, right? Like you just get busy. It's not that I don't like reading books. Actually, I find it incredibly relaxing, but I just don't do it anymore. I should probably do it more often. I know the last series of books I read was I read all the Game of Thrones books, which they're now over here keeping up my fourth monitor level. Most of them have pages, yeah, some of them. So what we're going to do is we're actually going to grab the final hit in our hit results. So we're going to say our actual or step 1 hits equals step 1 hits sub 0, and we should actually print out some information about this hit, shouldn't we? So we want the F hit result page. So we are going to want to print off effector step 1 impact point, and we're going to step 1 hit dot impact point. X, Y, Z. And let's also just kind of be super frickin' verbose. Let's also print out our step 1 start and our step 1 direction and our step 1 distance. Alright, that looks pretty good. So step 2, we're not going to do a ray cast because it doesn't matter. And step 3, ray to grab the normal of the surface. So we need to do our ray cast here, and it should hit. So what if it doesn't hit? If it doesn't hit, then like we should probably break and just be like, warn log, something is seriously wrong. We didn't strike a surface with our mantle check. So we'll just break out of the loop. That'll return. Let's actually just have us return sub delta t here. Actually, we're going to always do sub delta t, aren't we? So we should just chuck this right out of here. And if we get to the bottom of the loop, we're going to break out of the loop because we were successful. So let's make sure we got that in there. Alright, so here we are going to get our step 3 hit. And we are going to grab it and print it out. So step 3 location and step 3 normal. They're things that we want. So step 3 impact location is going to be step 3 hit dot impact point, and step 3 impact normal is going to be just impact normal. That's going to be the normal of the thing that we have struck. And let's go ahead and print these out. Step 3 impact and impact normal. Step 3 impact and step 3 impact normal. Not bad. Okay, so we have then got our locations and our corners, and we projected our vectors, and now we need to start sweeping our object. So let's do our sweep. So we're sweeping from our sweep 1 position in our sweep 1. What is our sweep 1 direction? Our sweep 1 direction is going to be perpendicular to the normal. So let's again be super verbose and do our sweep 1 direction. And that is going to be perpendicular to normal of collision. So sweep 1 direction, our sweep 1 distance is there. We're going to do it for every component, and we're going to throw it in the hits. And we're going to do our step 3 sweep hits. Or no, it's a step 1 sweep hits. And this is again wrong up here. This should be num minus 1. Step 1 hits. This should be step 3 hits. Step 3 hits sounds like some sort of CD you would buy. Hey man, what do you listen to? Step 3 hits. Wow, cool. So step 1, sweep 1 hits, or sweep hits, is going to be there. And we had another thing that's in the back of my mind. Yeah, this guy is screwed up. Alright, so if we actually collide, we actually don't even care here about this thing. We're just like, break. We're done. Alright. If we wait. Okay, yeah, this is step 1 sweeping, and we actually do need a break if this happens. Breaking in a loop chucks us out of the loop. So basically we're not going to test anything higher, because if we're sweeping and we're going up, 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 well, we're not going to go any farther up if we already just like struck something. So this is going to be sweep 1 impact and sweep 1. Yeah, we just need sweep 1 impact, and that's going to be the impact point. Yeah, impact point of this thing. So f vector sweep 1 impact equals blocking hit dot impact point. Again, this is super verbose. We're using a bunch of craptastic, non-efficient member variables and things like that, but I don't really care. We are going to fix that once we have things that work. If we actually hit anything with our sweep, bail out. Excellent. So now let's get to our final sweep. We're going to sweep the object in the sweep 2 distance. So we are now sweeping inverse to the normal of the thing that we hit. And if we collide, we will continue. Oh, this is a good point right here. I need to bool hit equals false. I need to say hit equals true, and this will break out of this loop. So hit if hit equals if hit. We need to break out of this loop. All right. Same over here. So we're gonna say hit equals false, then like hit equals true, and then if hit continue. So this is going to be, we're going to do from sweep to position, sweep to direction, sweep to distance, that's our component, and sweep, we need sweep to hits. So sweep to hits, if we actually hit anything, try the next iteration. This is going to be a sweep to impact. And if we didn't do anything with our sweep there, then we're good. Alright, so now we need to do our sweep and our movement direction for our other thing, so we can copy paste this, copy pasta this thing out here. So let's sweep in the direction of motion. Let's just double check these: sweep to, comp, sweep to. Alright, sweep 2 hits. This is going to be the sweep 1 hits. And we are going to go from our start position in our movement direction vector, which is rotated our normal to our collision. We're going to do our movement distance, so comp there, sweep 1 hits, again, sweep 1 hits, sweep 1 hits. This is going to be a sweep 1 impact. Why don't we call it something other than sweep 1? Why don't we call it continue? Nah, we'll just call it sweep 1. Okay, so if there was a collision, move to the point of collision. So we actually need the closest collision point is what this is saying to me. So we're actually going to need closest hit, and that's going to be starting equal to physics far enough. So we're going to say if blocking hit dot like distance is less than closest hit, then we're not breaking out of this. We want to set closest hit to the distance. And we're going to want the location of that, right? No, we just want the distance, and then we'll move by the movement direction vector in the distance. Alright, so if closest hit is less than physics far enough, then we had a hit. Otherwise, we move to the sweep location. So if there is no collision, yeah, so okay. So we're going to return delta t here, and we're going to set position internal to, actually no, we're going to drop ourselves onto the ground, aren't we? So we want to do the same thing up here. I'm going to say new position is equal to our start position plus our movement direction vector times the movement distance, and we're going to tell update snap to floor at delta t time and return delta t. Otherwise, we are going to need to get the point of collision. So let's see, we need to do, so this is going to be float percent is going to be the movement distance minus the closest hit. I mean, what the hell am I doing? It's going to be movement distance divided by closest hit, and we're going to multiply that by extra delta t. Yeah, it's going to be extra delta t there. And we are actually going to return, this is not percentage, this is the time taken. And we're going to do sub delta t plus extra delta t is going to be what we return. It's the time we simulated. And we need to move, if they're moved to the point of collision and then stick to the floor. So our new position is going to be new position plus start position times movement direction vector times the closest hit. So movement direction vector times the closest hit. And we're going to subtract a tiny float from that closest hit. And we're actually going to do a little check here. Let's say if closest hit is less than tiny float, then we're just going to return sub delta t. Just to prevent a degenerate case there where we might move backwards because the hit was so close that we actually like move ourselves out or something. We don't want to be doing too much there. So theoretically, we're done and FatSat can move. So let's compile it and fix all the errors and then fix all the actual other errors. Yeah, drumroll. No, this is nowhere near finished. This is just like, this is not going to work. Not a chance in hell. Yeah, what the fuck am I doing here? That's wrong. You got good chances in hell? Well, it's already broken, so we'll have to find a new hell. Let's call a sweep 1 start position. And so we need to make sure that start position here is not hidden. Looks correct. normal to collision. Let's see. Sweep one normal. Movement direction vector. Sweep one movement direction. Whoops. Yeah, it's going to be that. That and that. Okay. Movement distance. Sweep one move. Movement distance. New position. Initialize local variable. Step 3 ray collision distance. Do we even use this step 3 vector? No, we don't. Do we use this? No. 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 Okay, good. We don't need any of that crap. Step 1 hits. Step 3 hits. I'm just throwing some of our arrays outside of the loop just because I want to not create all the things. And I'm getting hungry. Alright, so new position is sweep one start. So let's say this is going to be our actual new position. We'll just do that twice. Just trying to use some new variable names. We're going to split all this functionality up later. It's kind of in a big mess of spaghetti at the moment, but that is totally on purpose. We're just trying to get it all on paper and test it a bit first, and kind of how I'm writing it is a bit exploded from what you would normally write. So it compiles. Let's see what the hell it does. I am predicting failure. Yeah, look at that, immediately. Exceeded max physics iterations for object. Let's see what our trace tag dash, let's see what we're doing. And look at all that. Blah. Darn. Well, that's why we put in the max physics iteration basic check, because we knew we were going to screw everything up. So, this should be a pretty easy case here. We've got our guys moving like this. So what we would expect is for the box to sweep up and to the right, and then, you know, forward, and then down, and all that stuff, and it's not happening. Yeah, tiny ledge. No. So, let's see what's going on. So, we did not hit anything. We have hit something. So, let's see what happens. Our sub delta t is hit distance divided by movement distance. Our hit distance is like 0, right? So our sub delta t is how much time has already passed, and our extra delta t is going to be delta t minus sub delta t. Doesn't look right, does it? Like delta t minus sub delta t should be, delta t should be, it's probably right, fuck it. So start position plus movement direction vector times sub delta t. So we've moved, extra delta t is less than the min physics. Extra delta t is less, so we're not doing anything? Wait, this doesn't seem right. If that was true, we wouldn't still be in this function. So extra delta t is totally not less than min physics sim time. Alright, so we are the sign of our velocity. Our velocity in the y direction is undefined. Our wanted velocity is this, so velocity is going to be negative, it should be 3,000, so our velocity should be positive. Our perpendicular to our normal is a negative 1z. Our normal to the collision is negative 1 in the y and a very small z. So perpendicular to collision we would assume would be up. Yeah, which is correct. So we rotated it. So our perpendicular to our collision, the velocity of our y is, so we are attempting to mantle, which we should be doing. All right. So our bounds are completely screwed for some reason. And of course it's our y vector that's totally screwed, so our corner is like jacked up. Okay, so we have struck with our array cast, which is step 1 start, which is our step 1 direction, our step 1 ray distance. And we're going to return sub delta t. Now I guess we should actually be returning delta t here because we found that we couldn't actually simulate anything at this point. It would only be if we actually snapped to the floor that we'd return sub delta t. This should be delta t. Hey Adam, how's it going? Just checking in on the stream or something? You don't have anything else going on? You don't have any sweet drawings in progress? Oh, you're hosting Johnny Utah. So you're done? You done working on stuff today? Or are you working on other secret things? Alright, so we snap to the floor because we're a good little fat sack. Building the editor. Oh, well, good luck. It shouldn't be broken, seeing as I'm building it. And the nightly build looks pretty good. It's building stuff right now, so it should be just fine. Unreal wasn't on your machine? Well, that shouldn't matter because you're building Unreal. Like, you don't actually need Unreal installed. You should just be able to run the editor as it is. And we're going to go up here and we're going to actually take a look at this calculate bounds thing. So the minimum y is being set properly. The minimum y is being set to. So if the min y is better here, otherwise minimax are being set. I mean, these look okay, right? Like min y, box min y, hitter box. Let me just print out the bounds. The debugger, we're running in kind of a halfway debugged state. I mean, halfway release state. So some of these numbers are going to lie to us. Yeah, that's right. Option 4. You should run that. What the hell is option 4? Run development editor? Yeah. It should work. I mean, did you get this like super destroyed playing Unreal Tournament? You just uninstalled the Unreal Engine. You're just like, this is bullshit. Flat cannon is crap. I'm done with this. And then you just nope the hell out. It's nowhere to be found. Oh no. It should work, yeah. We're all fine here. How are you? Alright, sub delta T and delta T. Our favorite brand of cereal is called sub delta T. So our bounds are... These bounds are just all sorts of screwed up. Like, it's saying our bounds are... Well, maybe they're not screwed up. Like, maybe they're correct. Like, our bounds are not our width and height. They're going to be our actual coordinates. So, are we at negative 25,000 y? We might actually be. Bunch of Dashkin story. Yeah. Can't really stream all the spoilers, can you? That's how it works. Why is our y at 0? Our y is like super... Step 1 start is the corner. The corner is... Why is the max y at 0? I think is the question. Max y, corner y, set to bounds max y. So probably max y bounds are screwed up. The t-shirt design didn't go well. What? What are you talking about? Are you saying we don't have t-shirts? Because you're crushing me here, man. I'm feeling crushed. There's like a lead weight. You hate it. Well, Just throw fat sack on a frickin' t-shirt. Everybody will buy that. It's amazing. It's fat sack. Who wouldn't want fat sack on themselves? He's just so cute. I don't. It can't go wrong. You're probably try harding the t-shirts too much. You know, like you're probably like, okay, I'm gonna make this amazing thing, and if you just relax, you totally do it. But what the hell do I know about designing things? I'm an engineer, not an artist. So my opinions on telling people to be creative are pretty much garbage. Just like a lot of the things that come out of this mouth of mine. So what is wrong with our bounds? Let's take a look. Screenshot sent to friend. Yeah, yeah. It's just a picture of me pointing. It's like, what the hell? What? Why is that the T-shirt? It's like he was busting my balls about making T-shirts, so I threw him on a T-shirt with a stupid expression on his face. That'll serve him right for giving me shit about T-shirts. All right, so box bounds are negative 25,000, and it goes to 0y. That's total horseshit. Because Fat Sack is not at 25,000 units wide. I guarantee you, no matter how fat the Fat Sack is, he is not 25,000 units wide. Yeah, so his location is at 26,000, so he's probably got a bug in our bounds calculation here. To calculate bounds, our max y is going to equal the inner box max y. Why? What's going on with the cached components? Let's take another stab at this. So, out of our cached components, our box here is it's looking like the max is negative 25,000. The min and max. Wait, the bound min and max are like the same? Max just didn't even get set, did it? If the inner box max x is greater than, because we're setting the max x y, like what? This makes no. Why is this messed up? Also, it definitely looks like our navigation bounds are just sort of screwed. So we're gonna have to find a better way to calculate the boundaries for the object. It looks like. All right. Well, let's see. What would be the correct way to do such a thing? And we can get the aggregate geometry of the object. All right. Well, anyway, Adam, good luck on the story. What? All right, you're gonna have to send me your IP address then, because it's probably that your IP address changed again. You can just send me that IP address in Discord. So basically, if you're not aware, basically, if you're to keep servers secure, what you do is you one of the things you use are firewall IP and you firewall specific IP addresses to the server. So like our perforce and all that, like you can't reach that. We got firewalls around all the things, and nobody can get to it unless you are a specific person, something like that, and coming from a specific location. And even then, you still need like our passwords and stuff like that to get in. So layers of security is what you do. So go ahead, Adam. Try it again. Should be good to go now. Maybe I should build the AABB. Maybe that's what I need to do. No, that's a static function. All right, so maybe that'll work. All right, good. Yeah, your IP address definitely changed by a whole hell of a lot. So keep blaming that Australian telco. I'm in. Well, we know you've made it as a hacker, Adam, when you start drinking a whole bunch of red wine and sitting at a desk with like 20 monitors, and you got the music from Password Swordfish playing, and then you actually change your password to Swordfish for no real reason, because I don't know why you would do that. Because everybody knows like creating like a virus is really just like you have like this geometric puzzle that you have to like put together, and that's all you have to do. Like if you're good at like a Rubik's cube, like you better watch out. Those people are freaking dangerous. So this is our amazing problem at the moment. We run over to the edge and oh no, we've got like our something is seriously wrong. Um, check goes off. So let's see what's going on. Buy more monitors and red wine. Hey now. Watch out, Adam. You're gonna have the Australian authorities banging down your door and asking you to figure out why their printers aren't working. You don't want that. Alright, so what the hell is going on here? That log is not helpful. Let's see what our box bounds are. We're not even getting the box bounds. What the frick? Alright, box bounds are just absolutely wrong. Like, look at that. Like, our box bounds for our characters should not be zeros. You know, that's some trash tier box bounds. Yeah, our starting position is such. Our wanted velocity is that. Surface normal is that. Movement direction is. Looks like it's to the left and then a little bit up. So we're like shunking a little bit and then box bounds. Yeah, our box bounds are just trash. So we're not actually calculating a proper geometry. So we have to go figure that out real quick. I'm starting to lose some gas here. I'm running out of steam because I'm starting to get super hungry. So I think I'm gonna have to do that. I'm gonna have to like take a break here and like eat some food. Because our calculating our bounds is busted. This function does not work. So let's just return nothing because it's garbage. Alright, so we need to figure out our bounding box stuff for our character. So we're going to need to go over all the components, grab the geometry off of those components. And from that geometry, build our own bounding box from all of those things. And I think I'm going to like shut down the stream and then go eat and all that and then come back. So I'm thinking like 30 minutes or so, and then I'll probably be back on. But my stomach's growling. So thanks for watching. I'm going to be back on to do more of this work and all that after lunchtime. Oh no. What did I hit? Shit.